guys, have your notes pulled up for section 2.5, day 2. And the first page, I'm going to show you another test on how to make sure that you're taking care of all your zeros, you're finding them all, things like that. So what you can do, let's say, I'm just going to skip it down here. Let's say that you have a 5th degree polynomial. And you're thinking, okay, I think it has 5 zeros. So it may have 5 real zeros. Or, since imaginary zeros come in partners, it could have 2 imaginary zeros and then 3 real. Or it could have 4 imaginary zeros and only 1 real zero. And so you get this grand idea, hey, I think I'm going to graph it on my calculator to give me some place to start. I'm going to see what I can send through synthetic division. And what happens if this is what you see on your graphing calculator? All right, I see 1 real 0. I wonder if that's all there is. I wonder if the rest are imaginary. So here's what you can do. You can pick a number above your 0. Any number. You can pick -1, 0, 1, 2, 3, whatever. And you can check to see if whatever number you pick is an upper bound. So let's say that I chose 3 for some strange reason. Let's say that I chose 3. I wonder if there are any more real zeros above 3, or if 3 is an upper bound for all the real zeros that exist. Does that make sense? And then I can pick a number to the left of what I think is a real 0, and maybe I'll choose anything. Maybe I'll choose -2. I wonder if -2 is like a left-hand boundary. I wonder if -2 is a lower bound, which tells me, if -2 were a boundary, then there wouldn't be any more zeros beyond that. Boundaries hold things in. So what I'm going to show you up there is let's test to see if -2 is a lower bound. And again, we could pick any of these, and for some reason I've chosen 3. Let's see if 3 is going to be an upper bound. Now, this test you're just going to have to memorize. So what I'm showing you, I'm going to send 3 through my 5th degree polynomial, and I'm going to send -2 through my 5th degree polynomial. And here's what we're looking for. When I send 3, if I'm checking to see if 3 is an upper bound, I'm going to send it through and I'm going to look at my results. Okay? If all of my results are not negative, so they have to be positive or they could be 0. If my whole row of results is non-negative, then yes, 3 is an upper bound. Yes, 3 is an upper bound. You know what that tells me? There are no more real zeros beyond 3. All right? And I'm going to check 2 for a lower bound. And here's what my lower bound test says. Do your synthetic division and look at all of your results. However they start, whether they start positive or whether they start negative, check to make sure that they alternate back and forth. Positive, negative, positive, negative. Or if they start negative, negative, positive, negative, positive. So it started negative. Just kidding. It started positive. So it goes positive, negative, positive, negative, positive, negative, yes. It passes the alternating test, and that tells me that -2 is a lower bound. Therefore, there are no more real zeros lower than -2. So what you see is what you get. That's the only real zero, which means the other 4 have to be imaginary. And one more thing, if let's say this number were a 0, 0 can be counted either as a positive or a negative when you're doing this test. Like, don't go telling everybody, hey, Miss Neal said 0 can either be positive or negative. No, that's not what I said. When you're doing a lower bounds test, anytime you have a 0, it can be what you want it to be. So if this were a 0, positive, negative, I would want to say this was positive, and for this test only, we would be able to count that 0 as a positive because it keeps going negative, positive, and so on. Okay, I can put 0 into whichever category I want to pass my test. All right. Let's see. Oh, zeros and linear factors. Okay. Remember how I said most of the time you're going to need a place to start. You all are not good at solving equations higher than a quadratic. Yeah, cubic, sometimes we can factor it. Quartic, this is going to be a time where you actually can factor a quartic. So it may not look like it. You may not be like, I have no idea. You can't pull out a common x term or an x squared. Okay, but this is set up very similar to a quadratic that you can factor. So check this out. We've got 1 x to the 4th plus 9 x squared plus 20. This polynomial is very similar to 1x squared plus 9x plus 20. This is totally factorable. So you know that when you have an x squared here and you have a single x term here, you're going to go 2 sets of parentheses. Automatically, this is the way I factor. I go x, x. And then I figure out the 4 and the 5. Is that what you do? To get your x squared, you have to have an x here and an x here. And you know that by putting an x here and an x here, it's going to do 2 things for you. It's going to get you your x squared term in the front. And when you do your outer and your inner, it's going to get you your x term in the middle. So, x to the 4th plus 9x squared plus 20, try factoring it like this. Ready? What do you want to put here and here so that when you multiply them together, you get x to the 4th? I think you want to put x squared and x squared. Now that does 2 things for us. This times this gets us x to the 4th. When I figure out these numbers, when I do my outer and my inner, that's going to get me my x squared term in the middle. So then I figure out what numbers go here and here. Okay, I factored it. Those are factors. Are they linear factors? No, they're quadratic factors. We're not finished. Okay, but I know that you know that these cannot be factored any further the way we know how to factor. So let's kind of skip the, let's go on to the zeros. I think y'all can do this. Let's find the zeros. I'm going to go x squared plus 4 equals 0. X squared equals negative 4. Square root both sides, and I get x equals the positive negative version of 2i. Right? You know how to square root a negative now. Let's do the next one. X squared plus 5 equals 0. Squared equals negative 5. Square root both sides. How many zeros did we just find? 1, 2, 3, 4. We found 4. Now, take each one of these zeros each one of those zeros, turn them into a factor. I think you know what to do here. Let's say that this were just x equals 2. Wouldn't you write x minus 2? What if this were x equals negative 2? Wouldn't you just write x plus 2? You know how to do that. So I'm going to go x minus 2i, x plus 2i. X minus I radical 5, x plus I radical 5. Those are factors. Are they linear? Yeah. X to the first, x to the first, x to the first, x to the first. They are linear. Linear factors. These up here were factors also. They were quadratic factors. They could kind of be factored further if we delve into the imaginary numbers, which we did. Okay? Alrighty. Well, this gets interesting. I'm going to show you 2 ways to do this type of problem. One way involves synthetic division, the other way involves long division. And so when I do this, I usually poll my class first and see how many of you prefer long division over synthetic division. And usually there's like 1 or maybe 2 people per class who raise their hand. Usually most people like synthetic division. I'm going to show you both ways. I'm going to show you synthetic first. It's going to get ugly. Our first round of synthetic division is going to get pretty ugly. Our second round gets pretty nice, and it's easy from that point on. But whew, this first round of synthetic division is going to get ugly. So notice what I've done. If one of my zeros of this quartic is 2i, find all the other ones. And it gets me started like as a reminder. Reminder, imaginary zeros, they always have partners. So if 2i is one of your imaginary zeros, then its complex conjugate is another imaginary zero. All right, so I already have 2 of the 4 that I'm looking for. So I grabbed one of my zeros and I'm getting ready to send it through synthetic division. I'm starting with a quartic. And when I'm done with synthetic division, I'm going to have a cubic that I still don't know what to do with, okay? Now, when I'm telling you, this is going to get ugly. So pretty much I've taken up my whole page here. I've spread out my coefficients, and I've given myself plenty of room. Not just one line, but plenty of room. It's going to get ugly. Won't last long, though, I promise. So here I go. Bring the 2 down. Multiply. Now, when I multiply, I get 4i, right? Just 4i. That doesn't need to be simplified. It can't be simplified. It's just 4i. So, add them together, and I get -1 plus 4i. Multiply. This times this, yes, you're going to have to distribute. So ready? 2i times -1 plus 2i times 4i is 8i squared. Whoa, wait, hold up a minute. I multiplied and I distributed, but this is negative 1. This term right here is really negative 8. So I really have a negative 8 and a minus 2i. Negative 8 minus 2i. So yes, I multiplied, but I multiplied and simplified. Why didn't I do it over here? I multiplied. I can't simplify this. Okay? Here's where it starts to really get messy. So I multiplied, I distributed, I simplified. Now it's time to add this black number with this black number. And I get negative 1 minus 2i. Multiply. This times this, yes, you're going to have to distribute. So 2i times negative 1 and 2i times negative 2i. I got negative 4i squared. Now, this can be simplified. So this I squared, this is negative 1. Negative 1 times negative 4, this term right here is going to become positive 4. This term's going to stay the same. This term's going to become positive 4. Positive 4 minus 2i. Now, add the black numbers together. Multiply. 2i times negative 2i is negative 4i squared. Wait, that can be simplified. I squared is negative 1. Negative 1 times negative 4, that's positive 4. Now add the black numbers together. Whew. You know what? I'm really glad it worked out that way because it already told me that 2i was a 0. If I had gotten any type of remainder, that would tell me that I royally messed something up. Okay, so I sent one of my zeros through synthetic division. Yep, it got pretty ugly right there in the middle. But it took me from a 4th degree polynomial to a 3rd degree polynomial. But look at the coefficients on my 3rd degree polynomial. This is hilarious. Ready? It's 2x cubed plus the quantity, negative 1 plus 4i, x squared, plus the quantity, negative 1 minus 2i, x minus 2i. That's my cubic. That's awful. So what I'm going to do next is I'm going to take this awful cubic. Let's send our other 0 through. Right? So here are my two zeros are positive 2i. Let's send our other 0 through, negative 2i. Send it through your cubic. Right? You want to send it through your cubic because if you send it through your cubic, your result is going to be a quadratic, and you all are good at quadratics. Okay, now this one won't be as bad. It's really going to separate that a little bit. This is really going to clean itself up nicely. So bring the 2 down, multiply, add, hold up, there, yeah, I lost a negative. Okay, so 2 down, multiply, there I am. Result is negative Got a little lost there for a minute. It's okay, just gave you time to catch up with me. All right, I'm going to multiply this, and I get positive 2i. Add, multiply, positive. Nice. Look at my result. I think that's factorable. Uh, 2 and 1. Oh, absolutely. 2 and 1, so now what did the problem tell me to do? Find all of the other zeros. Okay. So let's list all of our zeros now. Our zeros are, it told us that one. We quickly figured out that one. I have the 0 that goes with this factor. And the 0 that goes with this factor. And I didn't write them in x equals form. I probably should have, but oh well. Now, I did this one. There we go. I did this one using synthetic division. So it gave me one imaginary 0. I automatically came up with the other one. I did synthetic division twice. And the first time was super yucky. The second time really wasn't that bad. It cleaned itself up nicely. And I got down here to this quadratic, and you all are good with quadratics. You can either factor it or do the quadratic equation, or the quadratic formula. Let me show you doing the same thing. So I'm still going to get to this result. I'm still going to get to this quadratic, but I'm going to use long division instead of synthetic division. And I've got it all worked out, so I'm not going to take a whole lot of time with it, but I'll just show it to you, and I'll make sure to kind of pause and let you do a screenshot if you want to kind of investigate it further, and maybe you like that better, and you're thinking, that's the way I want to do it from now on. So, again, don't feel like you have to copy this down. Let me just show you the other way to do this. Here's my polynomial, my 4th degree polynomial. Here are my 2 imaginary zeros. Therefore, here are my 2 imaginary factors. 2 linear factors, right? I just did x minus this one and x plus this one. Okay. They're binomials. FOIL them. If you prefer long division, FOIL these 2. Ready? First, outer, inner, last. Collect like terms. This is negative. This term is positive. X squared plus 4. This is also a factor. It's not a linear factor. It's just a factor. So, yeah, this is a factor of that huge polynomial. This is a factor of that huge polynomial. This is a factor of that huge polynomial. The other day when we were listing factors of 18, do you remember how many factors 18 had? It had a ton of factors. Were they all prime? No. Same concept. It's a factor, that's a factor, that's a factor. That's not a linear factor. It's okay. All right, so anyway, I'm going to take this quadratic factor and I'm going to send this factor through my polynomial using long division. Now think about this. It's a fourth degree polynomial, and I'm dividing it by a second degree polynomial. So I'm going to get a second degree polynomial. So I do long division on it. Remember, all I really did, I turned my imaginary numbers into factors and FOILed them out. So I'm doing long division. See the answer that I got, 2x squared minus x minus 1? It's the same quadratic factor that I got the first time I did the problem with synthetic division. And now you can keep it going that way. So if you prefer long division, this would be where you want to take a screenshot and do it that way. Do the problems that way from now on. Okay, where am I? I think we're ready. Oh, yeah. We are ready to start creating polynomials. This is going to be fun. We're going to create polynomials. And just a reminder up at the top, if you're calling a 0, then x minus a is a factor. That's been going on for like days now. Same color coding and everything for you. So it says we're going to have a leading coefficient of 1. That's going to be nice. We'll do one later that doesn't have a leading coefficient of 1. So leading coefficient of 1. My zeros are negative 2, 2 plus 3i, and then I came up with this one all by myself because this one had to have a partner. Ready? Let's take these 3 zeros, let's turn them into factors. It's going to get difficult as we go further down the road. So let's start with the easy one. Ready? Normally you would just write x plus 2. I want you to think about why you're writing x plus 2. So really, I'm going to do x minus for my factor, and then this is going to go behind it. This is where the plus 2 comes from. So notice I've started my next 2 factors with x minus. And what am I going to put right after the minus sign? The 0. But wait, my 0 is a binomial behind a minus sign, which means you need to put your binomial in parentheses. Next factor, I started out x minus. What follows the minus sign? Your 0. Oh, but it's a binomial. There are my 3 factors. This one, and this one. Now I'm going to simplify them a bit. Ready? How do I simplify this one? I write it as x plus 2. How do I simplify this one? Distribute my negative. How do I simplify this one? Distribute my negative. Now, that's pretty much my polynomial. It's going to be a 3rd degree polynomial. You know how I know that? X to the first, x to the first, x to the first, or the fact that it had 3 zeros. It's going to be a cubic. And I'm going to finish it off and write it in polynomial form. So this is going to get pretty yucky. And but it is going to be kind of cool how all this imaginary stuff goes away. Like, yes, it had imaginary zeros. You would never know it had imaginary zeros by looking at the actual polynomial. We're going to do that in just a minute. So the first thing I'm going to do, yeah, it's going to get kind of ugly. I'm going to multiply these 2 together. So this one, let's keep it out there, okay? And then these 2, Let's multiply them out. I have a trinomial times a trinomial. It's going to get me 9 terms. Ready? I'm going to start with x. I'm going to distribute x to here, here, and here. Here I go. Is that what you all got? Times that, times -2, and times +3i. Okay, now let's concentrate on the -2. Let's take -2, like put your pencil on it, put a finger on it, whatever. Take -2, multiply, multiply, multiply. Hopefully that's what y'all got. Now, let's work on the -3i. Let's take the -3i, let's go multiply, multiply, multiply. So you should have gotten 9 terms. Make sure this is where most people mess up. The last multiplication that you do is this negative term times this positive term. So -3 times +3 is -9. And don't forget you're multiplying I times I, so it's I squared. Now, that's still out there. Let's work on the green stuff. Do you see anything we can collect that's going to, like, disappear? I do. Those cancel. See it? Your -6i and +6i cancel. Oh, and this 9i squared, this -9i squared at the end, well, I squared is going to be -1, and -1 times, this term is going to be +9. +9. So here's what I've got left. I have an x squared, -2x minus 4x, right? -4x. Here I've got a +4 and a +9. Isn't that cool, how that cleaned up? Now, one more. Let's multiply the pink binomial with the green trinomial. Here I go. X cubed wow. Totally worked backwards. We completely started with, see, what did we start with? We started with 1 real 0 and 2 imaginary zeros. We wrote them as factors. We multiplied out all of the factors, and we got a pretty decent looking cubic. Who knew? Who knew this cubic had 1 real 0 of -2 and 2 imaginary zeros? And notice too that by just writing the factors and all that, my leading coefficient did turn out to be 1, and that's what it said was going to happen. Now, on this next and final example, and I never have time to do this in class, we're getting to a pretty long video here. So it's going to be easier because I don't have imaginary zeros. Okay, so that's one nice thing. I don't have imaginary zeros. I've just got 3 nice ones. But my leading coefficient is not 1, and this we're gonna deal with this in just a minute. Okay, So I wrote out my zeros, here, here, here. I turned them into factors, here, here, here. Should make perfect sense. Now, ready? I'm ready to write my polynomial. So this is silly. I just wrote it like this. And I still have x minus 2. I still have x plus 3. But you know what? My leading coefficient's not going to be 1. And it's given me extra information in here that I'm not using yet. But nowhere did it say that my leading coefficient was going to be 1. So it's something, and I'm calling it A. Because typically A is the leading coefficient, okay? Don't know what it is yet. FOIL. Distribute. Here's what I've got. I've got a cubic polynomial. Only there's a factor out here that I don't know what it is. There's a leading coefficient and I don't know what it is. Now it's time to find it though. So now that it's time to find what my leading coefficient is, I'm going to go back up here and use this point. This is my x, this is my y. So wherever I see an x, I'm going to plug in 1, and wherever I see a y, I'm going to plug in 8. Did the math. A is negative 2. Okay. So wherever I read, oh, right here. This is where I wrote my polynomial when I didn't know what A was. Now I do know what A is. A is negative 2. So I'm going to rewrite this, but put a negative 2 there. Or you can go ahead and distribute your negative 2 in. And it looks like just a normal cubic. So when it doesn't say that your leading coefficient is going to be 1 and it gives you extra information, then go ahead, do your zeros, do your factors, and then put an A in front of your factors. All right, guys, good luck.